One of the tests that we typically run in an intro stats course is the one sample proportion test. So I'd like to give you an example from R where it illustrates the functions, commands that you would use to run the one sample proportion test. So install the normal packages, particularly here, this p-value functions package. So we're going to look at this hate crimes data frame. And first thing I'm going to do is to read it in, and then the dimensions of that. All right, so there are 28 variables, and there are 226,328 different incidences of hate crimes in this data set. You can see the different 28 variables here, including the state, where it occurred, a region, size of the city, the race of the offender, so information about the offender and information about the victims. So here's our example. There's typically the way these hypothesis tests work is that someone makes a claim, and then we go and collect data to see if the data supports the claim or it doesn't. Okay, so the claim that we're going to test today comes from the Southern Poverty Law Center, where they claim more than 2/3 of hate crimes are committed by whites. So what we're going to do from our big sample of 226 different incidences of hate crimes, we're going to use only those hate crimes from 2021. Along the way, we'll calculate the sample proportion, test statistic, and the p-value. Now, it's really the sample proportion is what we have to go grab from the data. In the end, we'll interpret the decision and what our hypothesis test actually tells us. So the claim is in the alternative hypothesis. Usually what we want to do, if the p-value is small enough, we'll reject the null hypothesis in favor of the alternative. And the alternative is what we generally want to show. It's generally our claim, but not always. In this case, it is. And the claim is that the proportion of hate crimes committed by whites is greater than 2/3. And I'll write 2/3 as the decimal 0.667. We'll assume a level of significance, alpha at 0.05. Now let's take a look at the groupings. There's our hate crimes, and notice we are going to use the variable offender race, which is right here. So you can see we have white, many are unknown, and so on. We're going to count them all up and then arrange them in descending order so you can see the most popular offenders of hate crimes. Well, many of them they don't know. A plurality of them they don't know. But you can see the biggest group is white. And so since we don't know those folks, some are white, some are non-white, we're just going to ignore them. And there are also these here, which they're not specified. Maybe they know them, but for some reason they didn't specify what it was. So there it is. And again, we want to get rid of the unknown and the not specified. So you can see my filter in 43. The offender race is equal to unknown. No, it's not equal to, because of the exclamation point at the beginning. And the offender race is not specified. So those were the two different levels of the variable that we wanted to ignore. Let's go ahead and do that. And then notice our new data frame, X2, is the data frame that does not contain the other ones. All right, so the number we need for our sample proportion is the number of hate crimes committed by whites, and there it is. And all the other ones are the non-whites. And if we sum up all the numbers in the count column, you'll see we have 126,000. So there are, of our 226,000, 100,000 of them, we don't know what the race is of the offender. So what I'm doing here in 58 is I'm assigning X to be the first label, or the first ratio group in count. So the first, here's count. The first count is the count that we want for the white group. And then we've got the sum, and notice I'm assigning that count, the white frequency, to X. I'm assigning the total sum to N, and then the p-value in our null hypothesis is the 0.667. There it is there. All right, we're going to take those three numbers, the X, the N, and the P, and we're going to put them right here as our first three arguments of the prop test function. And we're going to take these results. We have a greater than alternative, and we're not going to apply this correction. So we're going to run this to get the results of the one sample proportion test. We'll print those results out, and there you can see it. Here's all the output that it gives. Tells you we have X out of N. This is how you get your sample proportion. Get the null probability is the P0 that we've assigned 0.667. You have the p-value here. They give it to you in scientific notation. It's very small, 2.2 times 10 to the negative 16. And then so there it recognizes that the alternative hypothesis is true and that p is greater than 0.667. Gives you the confidence interval, and then down here it gives you the sample proportion. So we have 2/3, 66.7% is what was in the null hypothesis, and the claim was that the percentage of hate crimes that are committed by white is more than 2/3, more than 66.7%. And we did indeed find that it was larger than 66.7%. It was 70.6%. So we see a difference there of about 3.9 percentage points. And because the sample size is so large, that 3.9 percentage point is what we call statistically significant. P-value is less than 0, and we rejected the null hypothesis. So in summary, our claim was that the proportion of all hate crimes committed by whites is 2/3, 66.7%. We ran the test. We rejected the null hypothesis. So this one rejected. And so the only one left standing is the alternative. We would say that we reject the null hypothesis in favor of the alternative, that the proportion of all hate crimes committed by whites is more than 2/3. And that happens to be the claim. So in context, this means that there's evidence to support the claim that more than 2/3 of the hate crimes are committed by whites. So we have confirmed the original claim.